Okay, so in this video, we're going to go through um, IUPAC nomenclature. Okay, I wanted to put a picture of the organization so that you can see what it's like, but I mean, I didn't know how they would react. You don't want any copyright issues, right? So I was like, okay, it doesn't matter. You can check it out if you want. IUPAC is an organization. It's called the International Union of Pure and Applied Chemistry. Okay, and basically what it did is it did something very nice. It's just a bunch of chemists, right, from all around the world that came together, okay, and wanted to combine their knowledge, okay, and do something worthwhile. So one of the things which they did, they opened this thing called IUPAC, right, and it has many parts or groups or committees, right. One of the things which they then did was to make a group of people that focus on giving compounds names. And these names would be standard names that are used everywhere in the world. Because what they had before that was you could go to a country and find the very same compound you're dealing with in your home country being coded by a different name. And that would make you ambiguous. Ambiguous means you're not sure. Okay, let's say you want to do a project and then you're in another country, they give you a compound, it has a different name. How do you know it's the same one you're working with? Okay, and remember, things to do with chemicals are very dangerous. So, because of that, they devised a system. This group of people devised a system of naming, which is used everywhere in the world. And common names, or no, not common names, let's say systematic names, which are used everywhere in the world. Okay, the standard names. So wherever you would go to, you would know the IUPAC name of the compound and you would know what you're working with. Okay, so now let's just go through this. IUPAC, I'm going to go through now my slides or my notes. In this video, I'm not going to do much writing. Most of it is just going through what I've written down for you, just to give you a background of what you're going to be doing in the whole thing, right? Okay, so here it is. IUPAC nomenclature. This is a systematic way to name compounds. And this was devised based on the chemical structure of compounds, right? And we, as we said, that this system was developed by a group of people that are part of the IUPAC organization. And these guys are experts. These guys are experts. And they're working together to make a standardized way of naming, okay, that works across the whole world, a systematic way, rules or guidelines that you follow when you are naming a compound, okay, that are used everywhere in the world, right? Well, I'm going to go through those rules in the next slide, but first of all, I want to give you one more thing as a background, and this is this word that is going to keep popping up when you're going through your slides or whatever it is, and this is the word common name. Okay, this phrase, maybe it's not a word, it's a phrase or two words. Okay, this thing called common name, whatever it is, this just means it's not from IUPAC. Okay, when we say we are going through the common name of something, we are not going through its IUPAC name. The IUPAC name is the name that is made by the IUPAC organization. Okay, and this one is systematic. We know how to follow when we're naming, especially in organic chem. But common names are names that are used by people in a particular industry. Okay, it is the names that are used in everyday. If you look at this, I've said when we say common name, we are talking about the names that are used in everyday language. Okay, by who? By everybody? No, not necessarily by everybody, but by people who work with that particular chemical or who encounter it every day. Okay, I'll take you through some common names. So it doesn't have to be a name that you know. You might not know it. So when we say common, we don't mean to say everybody in the street knows it. No. When we say common name, we say this is the name that is generally used in the industry. Okay, the guys that work with this chemical normally call it this, although it won't be its proper name, its IUPAC name. Okay, so yes, don't confuse that. Although when we're doing our chemistry and we're naming our compounds, they will specify, okay? They can allow you to give the common name. Many of the times you're going to be using the common name and not the IUPAC name, okay? For many of the compounds. So just make sure you know that. IUPAC name and common name. Common name is the name that is used generally by people who meet that chemical or who encounter it every day. And this could be women in a kitchen, right? They could use, or men in a kitchen, people in a kitchen, right? They could use the name lime, okay? Or slaked lime. And they know what they're talking about, okay? But that is not the IUPAC name, but it's the common name. It's the name that is used generally by people who work with lime wherever they work with it, okay? Or it could be people in an industry that work in the clothing industry or whatever. You could go and say, may I have this chemical, and you name it by name. But that might not be the IUPAC name. So common name is the name used by in the industry, okay? People use it every day. Here are some examples of common names and IUPAC names, okay? And to show you that they are different, IUPAC names were made by the IUPAC organization. Common names are just what people use generally. And okay, before I go through these names, what I want you to know is IUPAC names are not only for organic chemistry, but we are going to be focusing on organic chemistry. IUPAC names are across the board, different types. Physical chemistry, okay? We use IUPAC names in physical chemistry. We use IUPAC names in any other type of chemistry, okay? Not just organic chem, okay? Now, here's some examples of some compounds. Ammonia, a common name. That's a common name. The common name of this thing is ammonia. The IUPAC name would be nitrogen trihydride. You see that they're different? Another common name is lime. The IUPAC name is not lime, it's calcium oxide. Okay? Another common name is laughing gas. Now, this thing called laughing gas, I know it can tickle you guys and want you to check on it. Laughing gas is a gas that is used generally in by anesthetics. It is used to kind of make you feel good, like when you're going through something. But listen, it's used in medicine for medical purposes. Maybe you're going through some operation, whatever it is. It makes you, it separates you from your feelings, I guess, a little bit. Okay? It doesn't really make you laugh. Sometimes it makes people laugh or giggle. That's why it's called laughing gas, but not all the time. It just gives you a relaxation feeling. Okay? But the problem with this gas is it can cause poisoning. Okay? So you can't just use it. So the common name is laughing gas. IUPAC name is nitrous oxide. Another common name, dry ice. The IUPAC name would be solid carbon dioxide. Different. You see, they're different. People will be saying dry ice. May I have dry ice? Right? The IUPAC name will not be that. It will be solid carbon dioxide. Common name, white spirit. IUPAC name, aliphatic petroleum distillate. Common name, acetone. IUPAC name, propanone. Common name, cyclopropane. IUPAC name, trimethylene. You see how they're different? So you're going to meet this in organic chem, these cyclo guys, and it's going to be acceptable. You can call something cyclo whatever, okay? You're going to meet those guys when we deal with cyclic compounds. And you are allowed to use the common name. Sometimes when you're naming, you're allowed to use it. Actually, when you made a question, I'm going to show you a question from maybe one of the past papers or whatever. You're going to see that they say, give the common name or IUPAC name for this, okay? So common name works. Cyclopropane or trimethylene, right? Good. So this is just a background that I wanted you to know. Now let's quickly go through how IUPAC actually works. Okay, then we'll be done. One more thing. How it actually works. This is a background to this IUPAC naming. The system developed by the organization called IUPAC. So IUPAC names are actually broken down into 3 parts. And these work like you should know that organic chemistry we are studying carbon, as we said, right? And when we study carbon, we study it like we study a human being. Let's say that. When you are giving a human being a name, or you're looking at the names of a human being, right? Depending on their level of education or knowledge or whatever, you can give them prefixes, and you can give them first name, and they can have a surname. So we know that every human being, when they are born, they have a first name and they have a surname, right? First name, whatever, surname, whatever. First name John, surname Doe, right? But this guy, if he goes and gets learned enough, we can give him a prefix like Professor John Doe. The prefix is professor. It is not always there. It is there when a certain thing has happened, right? It is there when a certain thing has happened. In this case, it is when you achieve, when you learn, and then you do some research or whatever. Now, you can also be called Dr. John Doe, okay? Or engineer, I don't know the prefixes, you know them, many other. Okay, advocate, honorable, whatever. Or lieutenant general, whatever. So now it keeps going on. Prefixes are put before your name. And first name is yes, you can have a first name. Then the last thing I want you to know also about analyzing the human name and relating it to this is your surname is what then tells us your family. Okay, the family you are from. We look at your surname and we know which family you are from. And that's the same thing here in organic chem. We have the IUPAC system. These guys developed naming similar to how human beings are named. So they were very smart, right? They made similar to how human beings are named. And they basically divided the name into 3 parts, but it doesn't always have 3 parts. It doesn't have always. It's like a human name. Does a human name always have a prefix? No, it doesn't. Okay, it does sometimes. So that's the same thing with an IUPAC name. Prefix is used in IUPAC when there is something called a substituent. Okay, so let me just go through the names. We said we have prefix, and then in the middle, the main name is going to be the parent name. Okay, we call it the parent name. Then the last part, which is like the surname, is going to be called the suffix, and this one is going to tell us which family it is from. So the IUPAC system, chemical names broken down into 3: prefix, parent, okay, parent or root name. So we can call it parent name, okay, or root name. Then the last is the suffix, which is put at the end. Now, like we said, prefix is going to be determined by the fact that do you have a substituent group or not. Substituents, here's definition, it is when you put some atoms attached to the main chain of your molecule. So you have a main chain. I'm going to show you how to find it out. Okay, you have a main chain, which is going to be the longest chain, continuous, the longest continuous chain. And then once we identify that longest continuous chain, if we have any other groups of atoms, and these groups of atoms we have like a carbon and something else, if we have anything else that is not hydrogen attached, then we can start to look at these substituents and analyze them. So we'll learn about the types of substituents and how to name them. Okay, don't worry about that. But if you have groups of atoms attached to your main chain, then we'll call that group substituents. And if they are present, you are going to have to give your name a prefix. Now, what will the prefix tell you about this substituent? It will tell you its structure, okay? It will tell you what substituent is there, and it will also tell you its location on the main chain or on the parent chain. Okay? So you have a parent chain and you have something attached to it. Once you have something attached to it, we have to give our name a prefix. And that prefix will have parts. So the prefix does 2 things. It tells you what it is that is attached. So it's going to tell you, okay, this thing is what is attached. And it's also going to tell you where it is attached. Parent name is just going to tell you the number of carbons that you have in the longest continuous carbon chain, or the main chain. Main chain is the longest continuous carbon chain. So that is what the number of carbons in that longest chain is what is going to determine your parent name. Parent name is always there, is determined by how many carbons you have in your longest continuous chain. Suffix comes from what family you belong to, what family, and we'll see how to know the family. We look at something called functional group, which is the DNA. If you want to know where somebody is from, you don't look at their size, you don't look at their complexion, You don't look at what they look like, because that can fool you. So when you want to know what a compound is, you don't look at the size. If you want to know its family, you don't look at the size. You look at the DNA, which is only a small section. And that DNA, we call it the functional group. Okay? We'll see what to do when we have more than one functional group, and we have to know the main functional group. The main functional group that is there is going to tell us the family. Okay? So and once we know the family, we will know the surname, or the suffix, the last part of the name. Last part of the name comes from what family you belong to. So what does IUPAC do? It breaks down a name into 3. Never forget it. That's like this last summary, the last part. Okay? It breaks down a name into 3: prefix, parent, and suffix. A prefix is not always there. It may or may not be there. What does the prefix do? It tells you about substituents, things that are not part of the main chain but are attached to the main chain. What does it tell you about that substituent? It tells you what it is and where it is. Then what else you need to know? What else comes? You have to know about the parent or the root name, the parent name. And what do we use to know the parent name? The number of carbons in your longest continuous carbon chain. Okay, then what is the last part? The suffix. Where does it come from? Your family. Which family are you from? Okay, and how do we know? Look at the functional group. Okay, that's it. See you in the next video. Bye for now.